Drones are fast becoming an integral part of our cyber-physical infrastructure. They have provided disruptive solutions in various applications for monitoring built environments. As drones are mostly battery-powered, managing their energy resources is critical. To highlight the significance of energy constraints on drones, consider a disaster recovery scenario where the mission entails identifying human subjects stuck in a flood-affected area. To survey the area of interest quickly and effectively requires addressing several challenges. These include optimally dividing the sensing task among the available drones at one's disposal, deciding on the altitude of the flight while considering varying weather and lighting conditions. Kindly attend our talk to know more on how we solve these challenges at BuildSys 2021.
Energy resources have become more common in many households. For example, solar panels and battery. There are also electric vehicle and its chargers, and also HVAC and its thermostat. And with the emergence of the Internet of Things, these energy resources now have network capability, and this leads to a new opportunity for grid optimization, where homeowners can volunteer those resources by letting the utility control them. So in our presentation, we are going to explore the opportunity and its challenges. For example, how can utility manage a huge pool of resources? Our work is called VPeak, and here is the date and time that we are going to present our work. So we hope to see you guys at the presentation.
Passive infrared or PIR sensors are ubiquitous in modern buildings. They're used in applications ranging from lighting, thermostats, parking, room reservation, and intrusion detection, to name a few. However, PIR sensors can fail. Here is an example of a PIR-based sanitizer dispenser that has stopped functioning due to the failure of a PIR sensor. To solve this, we developed PIR Medic, a framework for end-to-end fault detection and diagnosis that identifies and classifies failures in commodity PIR sensors. We accomplish this by characterizing the sensor physics, thereby leveraging physics for end-to-end fault detection and diagnosis. We validate PIR Medic using real-world deployments, including one at Starbucks and at the elevator of our building. To learn more, come join us at our talk, PIR Medic, Physics-Based Fault Diagnosis for PIR Sensors, during Session 1, Paper 2. See you there.
Welcome, I am Jonas van Gompel, and I will present a paper about the automatic detection and identification of faults in solar panels. Now, conventionally, this is done via visual inspection by technicians or infrared imaging using drones, but these methods are not cost-effective, meaning most faults are undetected. Now, this leads to energy losses and risk of fire, so clearly we do need an automatic and accurate method for fault diagnosis. And we will do this via machine learning. Now, the state of the art is quite accurate, but requires expensive sensors. And this is why we propose a method that bases its classification on the past 24 hours instead of on the single most recent measurement. This allows us to reach 86% accuracy, while still only relying on satellite and inverter measurements. Now, this is very important because this means that no installation of sensors is required to implement our method, which means that it's widely applicable and cost-effective.
People spend up to 87% of their time in enclosed buildings nowadays, and their comfort, productivity, and physical and mental health can be significantly influenced by the HVAC systems, which control the indoor air environment of the buildings. In these systems, sensors, in particular temperature sensors, play a vital role in collecting the real-time information of the buildings. However, these sensors are not always in normal working condition due to passive faults and active cyber attacks. Once the faults or attacks happen, diagnosing the problems and fixing the sensors often takes a significant amount of time. Can we expect that the HVAC system can still provide services when under faults or attacks? So, want to know more about how we overcome this difficulty? Come to our session on the paper Learning-Based Framework for Sensor Fault-Tolerant Building HVAC Control with Model-Assisted Learning.
Hello everyone. I am glad to present my work titled Learn to Chill, Intelligent Chiller Scheduling using Meta-Learning and Deep Reinforcement Learning. Intelligent scheduling of chillers has potential for savings as chillers are major energy consumers and are inefficient due to poor part loading at most times. In addition to scheduling them, using the leaving chilled water temperature set point as an additional control knob can help improve savings. This problem of scheduling chillers comes with a set of challenges like data availability constraints and scalability issues. So, how can this be done? Cooling load-based control is suboptimal as it does not consider individual chiller efficiencies at varying loads. Model-based predictive control is sensitive to calibration and model errors. Also, sufficient chiller data is required to develop chiller models with high accuracies. We propose iChill, a model-free approach to intelligently scheduled chillers. Please watch our full presentation to know more details. Thank you.
Hello, my name is Elvin Vendel from Carnegie Mellon University. In our work, we propose a scalable load flexibility model to predict the magnitude of load shedding events in commercial buildings with VAV systems. We propose a feature that uses terminal damper positions as a proxy for the thermal loading condition of the building that we call the thermal unloading potential. We use this feature as a regressor for predicting the magnitude of the load shedding event. We validated this approach through simulation in different climate scenarios, and we found a 55% reduction in error in comparison to models that use outdoor temperature as a predictor variable. Thank you. Looking forward.
Hey, my name is Lucas Spanger.
And I'm Austin J.
And we're from the Research in AI for Sustainability Lab at UC Berkeley. Now, we like sustainable energy. However, the volatility of generation means that you need several strategies to make sure that most of it's used. Now, imagine you're in a grid that has dynamic pricing and you're trying to implement demand response in your building. One way to implement dynamic prices we've tried is through reinforcement learning. However, a vanilla controller that outputs hourly prices and then watches how people respond, unfortunately, takes almost 30 years to learn before the price is lower than time of use or flat energy pricing.
On the other hand, if you pre-train the RL agent on an offline data set of transitions from simulated people with a slightly different distribution, you get an agent that learns on the order of 27 years faster and saves you on the order of $10,000 per year.
Hello, we present a camera-based luminance estimation and occupancy-aware lighting control for zero-energy buildings. We first build a pixel-to-lux mapping during a fingerprinting phase using the cameras and infrastructure, when the targeted area is empty. This mapping is used during the real-time for a luminance estimation. We use these cameras to also estimate the presence of an occupant, using state-of-the-art object detectors, and localize them to sub-areas in the current scene. Our system adjusts the lights based on the illuminance estimated using the image pixels and occupants present in the sub-area. As observed, the brightness percentage is increased to 10% and 15% in the presence of daylight, while it increases to 45% and 55% in the absence of daylight. Our practical implementation reveals 40% energy saving compared to operating baseline. Please attend my talk in session 4, where I explain CS Light in detail.
Hi everyone, I'm Ziyi Fan. WinSet is the dataset proposed by our team. It's a multimodal dataset with different window states. We select RGB, thermal, depth, LiDAR, and ultrasound sensors to collect our data. And for the window states in our dataset, we have 3 different classes, which are openness, lighting, and human behind. These window states may help our life in energy consumption, public safety, and community management. For example, if we monitor the window openness, we could prevent some energy consumption caused by the leakage of the air conditioner. We will show more details on how we collect data, some analysis and usage of our dataset. If you are interested in our work, please come at 10:40 this Thursday to join our presentation.
Thermal comfort is important for our health and our environment. Human-in-the-loop systems collect occupant preferences to create personalized temperature control models. But how do these models know which temperature you would prefer? The answer is occupant interaction. Standardized scales are used to ask occupants about their sensation, satisfaction, or preference to collect data for training models. But these scales have some drawbacks. A person who feels warm does not necessarily want a cooler. This can be avoided when we include at least 2 scales. But especially when we want to collect a lot of data, or if we want occupants to use our system over a longer period, this can affect the usability and introduce bias. In this paper, we address this usability problem and present and validate the thermal desirability scale using a survey with 100 participants. More details in our presentation on Thursday. See you then.
When COVID hit, many governments issued stay-at-home orders to contain the spread of virus. The sudden changes in daily life had a significant impact on the electricity consumption. Studies on energy markets observed a decline in energy demand and changes in the consumption behaviors during COVID. However, as an essential part of the system operation, how the load forecast performs during COVID is not well understood. Our work aims to bridge the research gap by systematically evaluating models, input data, features that can be used to improve the load forecast performance during COVID. Hopefully, what we learned from the impact of COVID-19 on load forecast could help us mitigate the impact of a similar crisis in the future. For details, welcome to our presentation in session 5. Look forward to seeing you.
Hi, my name is Joe from the University of Oxford, and I'm here to talk about our paper Quilt, where we infer the thermal efficiency of residential homes non-intrusively. Now, there's been some fantastic work in this space, and what this paper is really focusing on is how we quantify the uncertainty and really identify the scenarios and where it would work in the real world. For example, look at the graph. You see how with the same house, collecting with different data types and like different sorts of periods of data collection, we get vastly different results. So we need to quantify where things work. Now, how we do this, we use a Bayesian model to quantify uncertainty, we simulate scenarios beyond what's available in existing data sets, and we adapt it to work for cooling, as most algorithms just work for heating at the moment. Now, what this actually results in is we get improved accuracy compared to competing methods. We're able to quantify uncertainty for real-world use, and we can identify the scenarios where it does work and propose solutions when it doesn't, such as if there isn't enough data, perhaps we can do data collection over a period when the users are on holiday. So yeah, hope you check out our talk. Really appreciate your time and enjoy BuildSys'.
Hi there, my name is Praveen Sharma from NIT Durgapur, India. So this work deals with one of the most important and crucial aspect, that is air pollution. Government measures of deploying some AQMS, especially in a city, are inadequate to measure the air quality of a complete city. Hence, knowing about the environmental condition at a certain location, especially in personalized level, is a challenge. Now, what if someone wants to know the air quality of the nearby ambient? Then the most obvious solution can be to deploy an AQMS nearby, but it's an impractical and infeasible solution. Here our framework AquaMoho comes in. AquaMoho uses only a thermohygrometer which annotates the AQI at the target location through a pre-trained model, and this solution reduces the cost of deployment of a complete device. For further details, please refer to our paper. Thank you.
Welcome to our paper, Sharing Economy Meets Energy Markets, Group Purchasing of Energy Plants in Retail Energy Market. We are from Australian National University. With increasing deregulation, a large number of energy plants are offered in many countries like the US and Australia. Energy customers are able to compare and switch among diverse energy plants from multiple energy suppliers. Furthermore, group purchasing has emerged in retail energy markets, such that users can collectively switch to specific energy suppliers for better discounts by leveraging the aggregate purchasing power. In this paper, we study the problem of group purchasing for energy plants and develop an online decision algorithms. Please read our paper and come to our talk for details. Thank you.
Smart meter data analysis can provide insights into residential energy consumption behaviors. Apparently, energy consumption patterns change over seasons because of weather and temperature. But are these the only factors that lead to seasonality? Also, in many energy efficiency and demand response programs, utilities set seasonal time of use prices or tier prices that will affect different people's well-being and electricity bill at least. Seasonal variation in consumption is not well understood, but yet important to consumers for energy equity and to utilities for energy services. All of this lie in one research question of what is the relationship between seasonal variation in residential load and consumer social economics, which is exactly our work is addressing. So for details, welcome to our presentation in session 6. Look forward to
Hello, everyone. My talk is about activity-aware privacy protection for smart water meters. We all know that data is good and more data is better, and that the analysis of data from smart meters can lead to many benefits. However, it can also be used to compromise the privacy of individuals. And so we have a conflict there. So my paper looks at how should a water meter dataset be constructed in order to maximize the utility for analysis while also protecting the privacy of households. Furthermore, I ask what assurances can be given that the dataset can't be used by an adversary to compromise the privacy of individual households. To find out the answers to these questions, please come along to my talk. Thanks very much.
Hello everyone, my name is Wenpeng Wang and I am a PhD student at the University of Virginia. Today I'm going to present our work named UbiTrack, which enables scalable and low-cost device localization for Wi-Fi IoT devices with single antenna. So the number of IoT devices are increasing dramatically as a result of new sensor design, more computing power, reliable mobile connectivity, and easier production. As a result, we will soon be entering the world of Internet of Treating Things. A new challenge that is brought up by this trend is how do we manage all the deployed IoT devices over time? So think about this. Have you ever forgot where you put your smart devices? Can you mark down every position change of your devices? If the answer is not, can we design low-cost localization methods for these stuff? This is why we're proposing UbiTrack, providing a novel meter-level ranging for single antenna Wi-Fi devices using pairwise ranging and two-way channel state measurement, together with a novel cooperative localization algorithm using neighboring information. Our system unlocks a great potential for location-based services on these devices.
Are you tense looking at the high total electricity bill and the net power consumption? What if you get an appliance-wise consumption analysis? This motivates the domain of non-intrusive load monitoring. Non-intrusive load monitoring is a task for estimating the appliance reading given the aggregate power consumption. In 2014, NILM Toolkit was introduced to make the NILM reproducible. Toolkit provided multiple datasets in common format. It provided implementation of baseline NILM algorithms. In our talk, we present 2 state-of-the-art and 5 newly implemented approaches in NILM. The newly implemented models incorporating recent advances in neural networks can be potential state-of-the-art. We contribute converter for largest publicly available ideal dataset. We provide empirical comparison across various algorithms. For more information, we invite you to our talk at BuildSys 2021.
Anand Prakash, and I'm an engineer at Berkeley Lab. I'll be presenting query relaxation for portable brick-based applications. From writing one application for one building, metadata schemas such as Brick and Project Haystack have enabled developers to write one application and run it across multiple buildings. However, there are still some barriers that prevent the development of such applications. Developers are required to have a detailed understanding of all their buildings and their brick representations. Additionally, there can be different ways to represent the same building using the brick ontology, and both these factors significantly hinder an application's portability. What we've done is adopt query relaxation techniques for the brick ontology. We rewrite the query conditions for an application so that the results are returned even for a failing query while preserving the intent of the original query. This will facilitate the discovery of resources in buildings and ease the development and deployment of portable applications. We evaluate our approach over a set of brick models and demonstrate its use in the context of real-world applications. I look forward to discussing our work with you in detail at BuildSys'.
We present a search engine designed to help building managers more easily and effectively manage time series data coming from their building's IoT devices. To begin, users can issue a query such as temperature less than 70. Our system will quickly return results from temperature sensors matching the provided condition. We compare the user's query to several predefined queries and run query word net expansion to ensure the results are timely and relevant. Since it's often difficult to describe time series shapes using words alone, we also provide users the option to highlight a portion of an existing time series and save it as an event. They can then select their new event to search for all time series with similar shape. We call this query by example. Our query by example algorithm is an aggregation of feature-based cosine similarity and dynamic time warping.
Hello, my name is Aparna Hariharan, a graduate student at University of Texas, Arlington. The horrified Texas winter storm known as Uri occurred in early February of this year. Well, that was my first semester here in United States. This incident left us without power and potable water for several days. As you can see on the left part, images from the NOAA 20 satellite shows dazzling city lights across Texas before storm on January 31st and a substantial darker image following the storm and outages on February 16th. The impact of this storm on February 16th was such that more than 4 million people were without electricity. To stay up to date, the only thing we could do is look out for any kind of information shared on social media platform like Twitter, which is quite trending, by public agencies like TextDot or COD. So, do you think they provided the right information? Was social media a useful tool for these public agencies to disseminate the information? If you want to know more, please join me in my poster session. Thank you.
Hello everyone, I'm Daichi Watari. I'm a PhD student at Osaka University, Japan. I will make a poster presentation titled Improving DAG curve by Dynamic Pricing and Battery Scheduling based on a Deep Reinforcement Learning approach. The DAG curve is a graph that shows a steep net load curve in the morning and evening due to the solar power generation, and this is a serious obstacle to the introduction of solar power. This paper addresses this issue through dynamic pricing to prosumers and battery plant operations by a resource aggregator. The proposed method is based on a model-free deep reinforcement learning method. The results show both the standard deviation and peak-to-average ratio of net load are significantly improved when compared to a simple baseline. If you are interested in this paper, please come to the poster session at number 15. Thank you.
Hello. Buildings contain utilities like this boiler and hot water pump whose control and coordination is carried out by the building automation system. However, fault detection and diagnostics model rely only on process data and do not have the access to functional specification of the automation system. Hence, their evaluation can result in false positives. Also, the bindings to the data sources has to be manually engineered. To address this problem, we use knowledge graphs to describe the system construction, the process data, and the functional blocks involved in the automation. This helps us to contextualize our fault detection model using semantic reasoning and consequently avoid false positives. Also, semantic description of the process data using Web of Things thing descriptions enable us to have loose coupling with the data sources. Thank you, and we look forward to exchanging ideas with you during the conference.
My name is Han Wei. In this video, I'd like to introduce you to our project, which is about privacy-preserving hybrid sensing for parking monitoring. Nowadays, there are two major approaches to support effective data sensing and gathering in smart cities, namely IoT sensing and crowd sensing. Although IoT sensing and crowd sensing are different, they are also complementary to each other. In the literature, some research effort has focused on hybridizing crowd sensing with sensor networks. However, privacy issues are often ignored or overlooked. In this project, we integrated both approaches while considering their privacy issues. Particularly in our IoT sensing system, we put physical blurry filters in front of Raspberry Pi cameras to hide the identities of pedestrians, while in the crowd sensing system, we used cryptographic techniques such as cryptographic commitments, zero-knowledge proofs, and anonymous credentials to ensure user privacy and anonymity. Thanks for listening. If you find our project interesting, you are welcome to take a look at our paper.
Hello everyone, I'm Hari Prasanna Das. I'm a PhD student at UC Berkeley, and today I'll be presenting our work Unsupervised Personal Thermal Comfort Prediction via Adversarial Domain Adaptation. So personal thermal comfort models are a class of models that aim to predict an individual's thermal comfort as compared to the average response of a large group. Here we have a challenge that we often don't have thermal preference labels for general occupants of a building. So we come up with a solution in which we have some occupants as called source occupant, where we have thermal preference labels available, and we have some occupants for whom the labels are unavailable called as target occupant, and we adapt the model for the source occupant to be used in the case of a target occupant. To achieve that, we come up with a adversarial domain adaptation based model, and we align the source and target occupant datasets via their encoders, and we train a source classifier using source data, and so that we can use the source classifier with the aligned target encoder to classify the target thermal preference levels. We test our model on a dataset that consists of physiological signals of 14 subjects, including heart rate, activities, wrist temperature, body proximity temperature, and ankle temperature. And we also have environmental parameters. To test the proposed method, we have two paradigms. One in which we directly test the source classifier on the target occupant, and in the other case, we domain adapt, or we do the domain adaptation on the source classifier and then test it on the target occupant. We observed that when we perform the domain adaptation on the source classifier, the result or the classification performance is better as compared to directly using the source classifier for the target occupant. Thank you.
Hi, everyone. In this work, we carry out a comparative study of energy consumption of the conventional internal combustion truck and the modern electric truck traveling over the national highway subject to a hard deadline. We focus on understanding energy saving of the two types of trucks and the key contributing factors. We conduct our study based on extensive simulations using real-world data over the US highway system. We also factor in the power system energy conversion efficiency for fair comparison. The results show that on average, the electric trucks save 10% energy as compared to the internal combustion truck. And this saving will improve as power systems incorporate more renewable generation.
Hello, I'm Univoso from University of Madeira. I'm going to present a poster about how can social agents be used in order to balance the load in energy communities. In very simple terms, I'm developing a pro-social energy community simulator, which is an open source project to evaluate energy management schemes in communities. The main goal behind the simulator is to balance the demand and supply, hence reducing the need to acquire energy from outside of the community and ensuring that the community resources are fairly distributed. The simulator is composed by 6 models. Community generator allows to create an energy community. The consumption generator is used to generate the consumption profiles of the community. The renewable energy generator provides the tools necessary to generate the PV power forecasts. The community manager is responsible for identifying the consumption requirements of each member and distribute the time slots. The agent simulation model will enable the exchange of appliance time slots between agents. And finally, the performance evaluation provides the tools and metrics necessary to assess the performance of the developed load balancing schemes.
Hello, this is Tom from Rutgers. Our work is collaborated with UVA. Data gathered from sensory devices installed in smart spaces hide personal information that may arise privacy concerns. However, this data are needed to enable desired services. We propose a privacy-preserving framework based on GAN that supports sensor-based applications while preserving the user identity. In our network, the generator takes a random noise vector as input and generates fake data, which is evaluated by the discriminator. With a customized loss combination function, the generator reduces the loss of operational classifiers while increasing the loss of expositional classifiers. Our experiments on 2 real-world datasets suggest that compared to the original data, the expositional inference accuracy is reduced significantly, while the operational inference accuracy is only reduced by a small amount. This work provides an early step on privacy preserving in smart buildings.
Hi everyone, we are a research team from the University of Sydney. We're glad to be here to present our latest work. We studied the user privacy leakage from federated learning in non-intrusive load monitor applications. Deep federated learning is a technique to break the data silos in IOM. It trains a joint model without direct data exchange between users to preserve user privacy. However, the latest study shows that federated learning does not entirely prevent disclosure of private data in practical, such as in image recognition problems. In this work, we aim to investigate what sensitive data can be reviewed from NIOM applications with the federated learning framework. We experimentally studied the possibility of revealing the private training data from the publicly shared grading in a federated learning environment. The initial results suggest that both users' appliance status and house power consumption can be reconstructed in our experimental settings. If you are interested and want to know more about our work in detail, please check out our poster for more information. Thank you for your attention.
Sensor fault detection and diagnostic system. It consists of a smartphone application integrated with airflow and temperature ephemeral sensors to enable facilities crew to collect flow, supply, and zone temperatures from each zone with a simple walkthrough. This data is then uploaded to a cloud for further analysis using machine learning algorithms trained to identify zones' faulty sensors based on comparisons with the building data available from the building management systems. We developed 2 data-driven fault classifiers and compare our system with 2 state-of-the-art sensing fault schemes using the receiver operating characteristic curve, showing an improvement in the area under the ROC curve of 7.1% and 26.3%, and 12.9% and 55.1% in fault detection performance improvement for a 10% false positive rate.
Hi. As you all know, factories require well-defined environmental conditions for the production process and the well-being of human workers. Therefore, almost all factories have large HVAC systems to guarantee those conditions. The problem is that most of those systems have a very high energy consumption because they are either based on static extreme values or on very few sensor readings. So most of the time, we actually don't know how the air is flowing through our factory and with that how emissions propagate through our room. The common countermeasure is to just use our over-provisioned HVAC system. With the knowledge about the real situation, however, we could realize a demand-driven control algorithm. And this is where our low-cost 3D indoor airflow monitoring comes in. We designed a low-cost 3D airflow sensor based on differential pressure measurements that can be easily deployed in various locations. If you're interested in how this sensor works and how it can be integrated into a wireless sensor network, feel free to stop by in GatherTown or in real life at the conference.